Hello everyone, I'm excited to introduce you to DMiner, Dashboard Design Mining and Recommendation. Multi-view dashboards have gained tremendous popularity in data analysis for their ability to present multiple perspectives simultaneously. Creating a dashboard typically starts with creating views of interest, followed by arranging and coordinating the selected views. Specifically, this paper focuses on the dashboard arrangement and coordination. Why is this important? A dashboard with careful and logical arrangement and coordination maximizes the utility of your limited display space, enhances the clarity and impact of the information presented, and ultimately improves system usability. Despite its importance, however, achieving it remains challenging. Existing approaches offer some solutions, but they have their limitations. Some propose guidelines for multi-view visualization design, but these are often too abstract to provide actionable insights, such as drawing users' attention to the right view and making cross-view data relationships more obvious. Other tools, like Multivision, are more focused on view creation. They offer default layout templates, but these templates often require extensive manual adjustment to meet specific needs, making the process cumbersome and time-consuming. Moreover, I have a question for you all. When you are designing a vast system, what are the design guidelines that you mentally refer to? I suspect that each of us injects a bit of our own design knowledge into the design. Thus, inspired by this, our goal is to learn the design knowledge of arrangement and coordination from the existing practices, and utilize them for helping analysts design dashboards. To achieve this, we propose DMiner, a data-driven framework. I'll be walking you through each component of DMiner in the subsequent sections. First, we collected Tableau workbooks from GitHub, which contain rich information to render the dashboards, such as the visual encodings and coordination among views. Then, we proceeded with feature engineering to distill key features from the dataset. First, DMiner extracts the rich information from the workbooks. It extracts the single view feature of each view, in terms of data, encoding and arrangement. For example, the mark type for this visualization is area, and it encodes the data columns like shipping cost and shipping mode. Besides single view features, DMiner extracts the pairwise view features for each view pair, that is, the coordination. Thus, from the rich information of the workbook, we extract these features. Next, based on the single view features, we further infer the relationship of each view pair as other pairwise view features. For example, we can infer whether two views are neighborhood or not according to their arrangement. To summarize, we have extracted these features, including data and encoding features for each view, arrangement feature for each view, data and encoding relationship features for each view pair, and coordination and arrangement relationship features for each view pair. Moving on, with these extracted features in hand, DMiner then proceeds to mine design rules. Prior theoretical work has shown that features related to data and encoding are critical to dashboard arrangement and coordination. Furthermore, arrangement and coordination are inherently interconnected. Thus, we build the mapping relationship between these features. We then adopt the rule-fit binary classifier for each predicted target, resulting in 624 decision rules. This is one example rule, which suggests that, if view C brushes view D, then view C is the neighbor of view D. Armed with these design rules, DMiner further develops a recommender. Given multiple visualizations, DMiner explores all potential arrangements and coordination as candidates. The final recommendation is the candidate that aligns with most mined design rules. In summary, DMiner presents a comprehensive framework that spans from initial data collection to final dashboard design recommendation. We conducted a user study and an expert study to evaluate the effectiveness of DMiner. Starting with the user study, we recruited 12 participants to conduct a comparison study for 6 variants. The ratings show that DMiner not only simplifies the dashboard arrangement and coordination process, but also reaches human-level performance. While for the expert study, we recruited 4 experienced dashboard design experts to rate and justify the 22 processed rules. The average score came in at 4.44, which honestly leaves room for improvement. We will analyze it later. But first, let's highlight some positives. The top 5 highest-rated rules all received scores higher than 5.5. The right is their corresponding high-level design guidelines. Due to time constraints, I'll briefly introduce just 2 of these guidelines. The first one says, adjust the size of the view according to the importance of the view. The rule underlying this guideline states, if view A is text but not text table, then view A should be of the height of width of 1. Expert 2 confirmed that text view is usually used as an assistive view, does not have too many meanings. It should equipped with either the smallest height or the smallest width. Expert 1 stated that size of the view should be related to the importance of the view. The second is overview first, then details on demand. This guideline is supported by two corresponding rules. First, text views should be positioned at the top right, top left, or at the top. Second, views that contain more data fields should be placed below those with fewer fields. Expert 1 explained the rationale behind the first rule, text view serving as overviews should be at the top. As for the second rule, Expert 2 and Expert 4 stating that views with fewer fields are likely to serve as overviews or contain more coarse information. Thus they should be on the top. While our findings have yielded some interesting and actionable design rules, there are still some limitations of our tools. First, our rules are highly dependent on the dataset we've collected. One of the rule is that text view should be on the top of the dashboard. This is because most text views in our collected dataset are statistics, serving as an overview rather than word clouds. Secondly, experts' personal experiences significantly influenced the evaluation scores. For example, the rule, scatterplot should be on the rightmost, received an average score of 3.5 with a high variance of 3. Expert 1 uses scatterplots to show specific details and agreed with the rule. While Expert 3, who uses scatterplots as TSNE reduced overviews, prefers them to be on the top or left. Lastly, we encountered issues of shortcut learning in our algorithm. To illustrate, consider 3 inferred rules. Rule 1 is that if you are wearing shorts, then it is summer. Rule 2 is that if it is summer, then you are eating ice cream. Rule 3 is that if you are wearing shorts, then you are eating ice cream. The third rule, derived from the first two, lacks semantic and could be misinterpreted or found confusing, leading to lower evaluation scores. To sum up, we proposed DMiner, a data-driven framework, for mining dashboard design and automating the layout arrangement and view coordination for MV dashboards. Thank you for listening.